All right, so I wanted to show you what I'm using. I don't know if I explained it um, before, but I got myself some of these ball bearings, and I'm using the ball bearing on the end of a 3D printed um, part here that holds the ball bearing in there. Of course, I glue it in there. And then, along with the um, what do you call it? The carbon fiber rod, which that is not it. So I showed you guys the first one, which was done with just 3D printing. And then if I can find my carbon fiber rod, here it is. So like that. And then of course the magnet, this one right here, is right there. All right. That was my wife asking for paper towels. And then, of course, up against a piece of glass, or in this case, like a metal shell. So there's almost no contact, right? The contact, if you can see there, but it doesn't get blurry, excuse me, is very minimal and very slick. I mean, it moves beautifully. So much so that I can spin that by hand and it'll go forever. I've actually never really timed this to see how long it would go. Anyway, you see what I mean. It goes really far. And it was funny because when I first set this up, I had it pressed up against the two ball bearing ends really tight, where you're not supposed to really do that. So now I have it, you can see it, it kind of moves. So I can either do it on that side or I can stop it and do it on that side. But either way, it goes forever. I'm not going to put you through another spin like that. But yeah, so I'm printing out a new cylinder right now for, where is it? For two of these guys. Two of these 12 by 12 millimeter by 75. So it's like half inch by, I think that's like 4 inches or 3 3/4 inches. But I had two of these in a nice round shell before, but the hole wasn't big enough for the 8 millimeter carbon fiber rod, and I ridiculously tried to drill out the hole, and of course it made it completely lopsided. But these are going to house the smaller, oh shit, these are going to house the smaller of the two ring magnets that I have. I've got these large ones which work really well. I mean, you can see there, that's not going anywhere. But I want to try it with some smaller ones, because I do have these guys here, which are smaller, but they're still big enough for the, I think it's a 5 millimeter magnet that goes right there. That'll sit in there, and I think it'll be even tighter. And someone asked me online if I tried the no backing situation that I was talking about, and I did some experiments, and I don't think it's gonna work. I think it'd be too complicated or just not work at all. So right now this was the test print for the new cylinder for those magnets that I showed you just recently, or just a couple minutes ago, and it's like a 3-hour print. I'm like, oh. But I'm printing it with almost no infill, which is kind of dangerous, but I'm also going to print out some sleeves that go over it. And so the whole thing will be a lot faster to print. What else? Oh, I got some glass, so I'm going to try glass on the back of this instead of the pieces of metal that I have in there, because the glass, I think, is going to work a lot better, especially when I'm using this type of setup with the ball bearing up against the glass. Let me see if I can get the glass out and show you. And I got the glass cutters that G-Law turned me on to, which I think is going to be really good because I can cut the glass. But then I got these, so this should work really well with this, and they'll go back here like this, and then that'll go in there, and actually that might be just right. I don't know. I'll have to get, yeah, no, I think I'm going to have to do the glass cutter thing. And I got them. So, and these are really inexpensive. I got these guys, and they come in all different sizes, and apparently there's, I don't know if it's got diamond dust on there or whatever, but I can cut different size, and I'll probably use thicker glass than this. But anyway, that'll work. Oh, and I have not given up on the solenoid motor. So I have two JL94 circuits in parallel through the power leads, and it is going nice. Especially with, so I'm doing what Sky Collection told me to do. Run these through their power inputs in parallel. And it's going really nice. What I need to do is take some measurements off of this coil, this top one, and see what kind of power I'm getting. But man, I love this thing. I have it running on 14 volts right now. And everything seems to be okay as far as heat is concerned. None of the chips are overheating. The neon bulb is getting hot, but that's what you expect with a neon bulb. Let me turn it down to 12 volts. Yeah, there it goes. Still running, still going strong. But I have to figure out what experiments I want to do with this. I had so many in my head, and then I got hooked on the MagLev thing. I wanted to get that right, and I finally got the MagLev right. So yeah, it's working good. It's still here. Oh, and one of the reasons why I delayed working on this even more is because I blew out the two capacitors on these two JL94 circuits. And so I had to replace them, and I did replace them. I didn't replace them with the same exact ones, but they seem to be working just fine. But these two JL94 are different than these two. Hold on. Than the other two I have. So these are almost the same, but this one has an extra out port for getting power out. These two don't. They just have an input and an input coil for the power and an output for the coil, which is fine. I mean, it's absolutely fine. I've got two of these that do have the extra output and two of these that don't. So I can use them in conjunction with each other to have one help to power the circuit and the other one to help generate, still running them in parallel. Anyway, I thought I would just explain why I had put this away for a while, other than the fact that I wanted to do the MagLev and I wanted to do it right finally. I mean, these were okay, you know, but they're nothing like this guy here. This guy is really good. I love this guy. I had to put him on the floor there because my area is freaking pigsty. It is so bad. I got to clean up. I mean, I've got coils and wires and, 3D printed parts everywhere. I have just got to straighten this out. Here's the ball bearings I was talking about before. But yeah, this is all of my successful and failed projects. I got a couple over there too. I really got to clean this up and straighten it out. Anyway, just wanted to show you guys that. Ciao. So I took this out of its frame or base or stand, whatever you want to call it, for two reasons. One, I wanted to weigh this minus the rod and the end pieces, because I think G-Law asked how much this thing weighed, because I think he was surprised that these ring magnets would hold it up, because it looks like it weighs a lot more than it is. But remember, there's no resin like the other MagLev that I made, where I made them with resin, which is really heavy. In fact, this smaller rotor that's fully resin is almost the same weight as this. This is a little bit heavier, obviously, but not by much, because again, come on, get over there. God, that's why I hate hate these things. There we go. The PLA is relatively light, but I wanted to test out, I also wanted to see if the depth that I made these was correct. And pretending that there's a ring magnet in here and the ring magnet is flush, when I put that in and I hit up against the glass, it sits differently than here. In this setup, it sits a little bit proud of the outside, which if it didn't have the one over here, if it didn't have this other one to stop it, would force it out that way. I think that with this setup, with it sitting not proud, but, oh, come on, I'm trying to do this shit with one hand. Sitting inward a little bit, it's the opposite of this guy here. So it's not sitting proud, which I think would then mean that this magnet would get pulled in this way instead of being pushed out this way. So if I can get this guy in here so you guys can see, if you can see, yeah, there we go. This is in here and I can feel it. It's being, well, actually it's not being pushed or pulled. It's actually perfectly balanced because it's right almost dead center of that ring. So I don't know what would happen if I were to just, well, actually I could put the magnet in there and see. I mean, yeah, it can't, yeah, I could put the magnet in. All right, hold tight. All right, so I've got the magnet in there. South pole's facing out. Let me put this glass there, see if I can hold it tight, and then try to push this guy in there. I don't know if I can get it in there, though. Oh, there it goes. No, it's being pushed out. It's being forced out the other side. So I would have to successfully demonstrate it. I would need to either clamp or glue that glass piece there and then try to, yeah, I don't even know if this is going to work. This may be too tight because it really wants to, yeah, I would need to back this up with something. Let me see if I can set this up. So I wasn't able to do it on camera, but I set this up. Let me get this out of here, all these freaking magnets. I set it up and I clamped, so to speak, I clamped the glass behind there and it worked. It sat up against there. Again, instead of pushing, it was doing more pulling, but that's fine. I don't see that being a huge issue. The pulling versus the, or the pushing versus the pulling versus the pushing. So I think that will work. I will definitely need to glue these magnets in here, though. They're not a push fit like these guys were, which is no big deal. But that will work. That will work. So I've got some new ball bearings and endpoints over here glued up. So let me go back to the drawing board. Let me go see how my 3D printer's doing. Ciao. All right, so I stole my wife's cooking scale. And let's see what this guy comes out to. So in grams, 558, and pounds, that would be 1.3 3/4. So I go with the grams. So 558 grams, a little over a pound. 1.3 pounds. So that's actually not a lot. That doesn't weigh a lot. All right, I just wanted to show G-Law that. So yeah, it doesn't weigh a lot. It's not that heavy, and these are really strong neodymium magnets. I mean, really strong. I had to be really careful. Plus, I cheated and I put magnets on the outside here. I put magnets on the outside here, which helps draw that in. I don't think I needed it, but I did it anyway. I'm going to take these off just to prove that I don't really need those. Anyway, 558 grams, 1.3 pounds.